Good morning to all. I am Dr. Dhondiba, Assistant Professor of Chemistry, Government First Grade College, KR from Bangalore. Today I am going to discuss about uh, 18th session of chemistry and the first session of surface chemistry, which belongs to third semester BSc affiliated to Bangalore North University. In this session, I have to discuss about review of surface phenomena, theories of adsorption, that is a Freundlich's adsorption theory that I have to discuss in this session. The main objectives of these sessions are the meaning of absorbate, adsorbent and adsorption. Then types of adsorption with meaning, then adsorption isotherm, then theories of adsorption isotherm, that is a Freundlich adsorption isotherm. These we have to discuss one by one in this session. Now, the after completion of this session, you will know about what is mean by adsorption isotherm, type of the adsorption, then Freundlich adsorption isotherm. You will know after this completion of this session. Then before discussing to this session, you already know about what is mean by adsorbate, adsorbent and adsorption, and it also be known about isotherm. Again, you will also know about how to plot the graph that you have already known before this commencement of a session. Now, introduction of this session. The increase in concentration of the gas or liquid molecules on the surface of a solid than in bulk is called adsorption. Therefore, here the definition is given for that is a adsorption. The increase in concentration of the gas or liquid molecules on the surface of the solid than in the bulk is called that is a adsorption. It is a surface phenomena. It differs from absorption, that the substance absorbed is not found on the surface alone but are uniformly distributed throughout the bulk of the medium. Example, the adsorption of nitrogen gas on that is a surface, a tungsten surface. Therefore, here these are the two terms are there. One is adsorption, another one is that is absorption. Absorption is nothing but bulk phenomena. Suppose we take that is a sponge when dip in a water, then water will be uniformly distributed throughout the sponge. The whole body of that sponge will be absorbed by the water. Therefore, that process is called that is absorption. But adsorption is nothing but it is the only surface phenomena. Whatever may be exposed, that is the only surface due to having a active sites or rough surfaces on the surface of that solid, then gas or liquid can be absorbed on the surface only. Suppose we are making the painting on the surface of the wall or that is wood, that will be nothing but it is a adsorption phenomena, but in bulk it is not takes place. Therefore, here the example is adsorption of the nitrogen gas on the tungsten surface. Now coming to that is what is mean by adsorbate. The substance which gets adsorbed on a solid surface is called that is a adsorbate. Therefore, a substance, anything which get absorbed on a surface of solid is called that is a adsorbate. Adsorbate is substance which is going to attack on the surface of the solid. Other surface of the solid is called adsorbate. Then adsorbent. Adsorbent is nothing but the solid that takes up the molecules on its own surface is called that is a adsorbent. Adsorbent is nothing but it is particularly solid or is a rough surface which take the other molecule of the gas or liquid on its surface is called that is a adsorbent. For example, you in reaction, no, one is a reagent, another one is substrate. Substrate is nothing but big, that is a molecule, and whatever maybe things changes takes place in the substrate only. and reagent is nothing but a small species which will going to attack on the substrate. Therefore, reagent is act as a adsorbate, and substrate is act as a adsorbent. Okay. Therefore, in some cases, both absorption and adsorption takes place simultaneously, and this phenomena is called that is a sorption. Sorption means, what is mean by sorption means the process in which takes both adsorption and absorption simultaneously, called that is a sorption. An atom or in, an atom inside solid experiences attractive forces in all direction due to similar atoms surrounding it. Hence, the attractive force became zero, whereas atom on the surface experience the attractive forces or residual valencies of forces. To balance this residual valency force, the surface atoms form a bond with other as a result of phenomena of adsorption. This means here usually in the particular solid, inside the solid, a atom can be surrounded by other similar atoms. Therefore, attractive force will be exist, and that will be became zero. But consider the same atom on the surface, that will be attracted by the inner atoms, but opposite direction there is no atoms will be present, because only it is a wall of the container will be there. Therefore, that side the force will not be there. Therefore, the attractive force will be experienced on the only one direction inside. Therefore, that molecule undergo a pressure, and therefore the attractive force will not be give that is a neutral, and therefore it attraction which takes place the surface with bonds, and therefore it is a adsorption is takes place. This is called as a adsorption phenomena. Then in adsorption of the gas or liquid molecules retain on the surface, hence the it is a spontaneous process in which the delta G for the adsorption is negative. Therefore, the spontaneous the adsorption phenomena is a spontaneous process in which the delta G will be a negative. Then the Gibbs free energy, from the Gibbs free energy equation, delta G is equal to delta H minus T delta S, where delta G is less than, that is 0, means it should be a negative. When it is possible, then T delta T delta S, therefore product of the temperature and change in entropy should be a greater than 0, because it is a minus, and the delta H should be a negative. Hence the adsorption is the exothermic process. Exothermic process, we say that is the delta G should be a spontaneous process, and if delta H is a negative or less than 0, hence this adsorption phenomena is a exothermic process in which the heat energy is liberated. Then coming to that is the types of adsorption. Depending on the type of bond formed at the surface of the solid during the adsorption, the adsorptions are two types. One is called that is a physical adsorption, another one is called as a chemical adsorption. In physical adsorption, the adsorbate is held to the surface by a solid weak van der Waals forces. Therefore, the force which is responsible between the adsorbate and adsorbent is by the weak van der Waals force. Weak van der Waals forces called that is a physical adsorption. Therefore, example for this adsorption of water vapor on the crucible. Second one is in physical adsorption, in in chemical adsorption, the adsorbed molecule is very often dissociated. The molecules of the adsorbate are held to the surface by adsorbent by a chemical forces. Therefore, we say that is a chemical adsorption is nothing but simply the chemical forces are responsible to hold the surface molecule, or that is hold the adsorbate and adsorbent is called that is a chemical adsorption. Chemical adsorption. The physical adsorption means it is responsible for weak van der Waals forces to hold the adsorbate and adsorbent molecule, whereas in chemical adsorption, these are the hold together by a chemical forces or chemical bonds. Example for that, the oxygen is adsorbed by the tungsten or charcoal hydrogen on nickel. These are the example for that is a chemical adsorption. Then coming to that is what are the differences between physical and chemical adsorption. The here physical adsorption, another one is chemical adsorption. The weak van der Waals forces are involved in the holding the gas molecules to the solid. Means the weak van der Waals forces are responsible to hold the adsorbate and adsorbent molecules together, whereas chemical bonds are involved in the holding the adsorbate and adsorbent molecules or gas molecules on the solid surface. Gas is here in the both cases. Gas is nothing but it is adsorbate, and adsorbent is nothing but that is solid. Here low heat of adsorption is takes place, but in chemical adsorption high heat of adsorption is takes place. This will be a in physical adsorption it should be a multi-layer adsorption, but in chemical adsorption it is a mono-layer adsorption will be takes place. Then here the adsorption occurs at low temperature, whereas in chemical adsorption the adsorption occurs at high temperature. These are the few differences between physical and chemical adsorptions. One more will be there, that is the rate of adsorption increases with increase in pressure. Here chemical adsorption, the rate of the adsorption decreases with increasing in pressure. These are the few, that is the differentiates between or distinguish the differences between physical and chemical adsorption. Now coming to that is the adsorption of the gases on solids. Gases get adsorbed on the finely divided metals such as nickel, platinum, palladium, iron, etc. The extent of adsorption of a gas on a solid surface is affected by the following factors. The first one is nothing but nature of the adsorbate. Second one is nature of the adsorbent. And third one is effect of pressure. Fourth one is effect of temperature. And fifth one is activation of adsorbent. These are the factors affecting on the process of adsorption. Now come to that is the theories of adsorption. Adsorption isotherm, that is in the theories of adsorption, the adsorption isotherm. At constant temperature, the relation between the amount of substance adsorbed by the given amount of adsorbent and the equilibrium pressure or concentration of the gas is called that is a adsorption isotherm. Here simple, what is mean by adsorption isotherm means at constant temperature the relation between the amount of substance adsorbed by a given amount of adsorbent and the equilibrium pressure or concentration of the gas is called that is a adsorption isotherm. The several theories have been proposed to explain the experimentally observed facts that at the constant temperature, the extent of adsorption of a gas on a solid increases with increase in pressure, namely Freundlich's adsorption isotherm, Langmuir adsorption isotherm, Brunner, Emmett and Taylor, or that is BET theory of multi-layer adsorption isotherm. These are for your syllabus and we have to discuss one by one. The first one is nothing but Freundlich's adsorption isotherm. Freundlich proposed the following empirical equation to represent the variation of adsorption per unit area, that is a or mass with the pressure. The y by m is equal to k into p to the power of 1 by n. This is called equation number 1, and this is the empirical formula is given. There is no derivation for your syllabus. That will be directly come divided by y divided by m equal to k into p to the power of 1 by n, where y is the amount of gas absorbed on mass m of the adsorbent, and p is equal to, that is the equilibrium pressure of the gas absorbed, where k and n are nothing but constant. Taking the logarithm log on both sides to the equation number 1, then we get log of y divided by m equal to log of k into p to the power of 1 by n. Then again log y divided by m equal to, it is the expansion, this is the product of the two, therefore I can write that is the log of k plus log of p to the power of 1 by n. Again the formula, that is we will get the log k plus 1 by n log to the log of p, and a graph is plotted y by m versus or against pressure. We will get at a particular temperature, that is called as a isotherm. Isotherm is nothing but a graph of y by m against, that is a pressure at a constant temperature is called, that is a isotherm. Isothermals or isotherms means a series of curves are obtained at a different constant temperature by plotting y by m against pressure, called that is isotherms or isothermals. Now here at 0 degree Celsius temperature, the temperature remains kept constant, and how it is adsorption y by m against the pressure, it will takes this like curve, this will be get. Again the taking the lowering the temperature, then another one will be get at minus 20 degrees Celsius, this will be a curve will be get. Again minus 50 degrees Celsius it will be get, that is this type of the curves will be plotted. By plotting log of y by m versus log p, a straight line is obtained. After that is plotting log y by m against log p, a straight line curve is obtained, and it is a intercept to the y-axis. Therefore we will get, that is this like curve. This is the intercept is nothing but it is a log k, and slope will be a calculated. How it is a slope will be a calculated. The slope of the curve actually, that is here a triangle will be there, that is ABC. Therefore slope is equal to dy by dx, means here usually the AC divided by BC, but here what happened here, the slope is equal to AB divided by BC is here written, but actually it is not correct. AC divided by BC will be a, it should be a change in y-axis, means dy by dx means AC divided by BC. It should be a AC, not AB. Okay, this is equal to 1 over, that is a n, 1 over n. Then slope 1 over n is it is will get, that is this slope, and from that n can be calculated, and intercept k is equal to log k, hence k and n can be calculated. Now coming to, that is the limitations of this theory. First limitations of this theory is goes to Friendly's adsorption isotherm is applicable only at low pressure, and at high pressure it deviates. Deviations are observed, means this theory is applicable for only low pressure, and high pressure it is deviates, it cannot be applicable. Second one is it has a only theoretical significance. It has a only theoretical significance. It is not a practically, but we have just a theoretical significance. Now So far we have discussed about the meaning of adsorbate, adsorbent and absorption, then type of adsorption and differences, then adsorption isotherm, then theories of adsorption isotherm in which the Friendly's adsorption isotherms, then limitations of Friendly's adsorption isotherms. So far we have discussed these points. Therefore, I will check for your knowledge how much you have understand by asking some questions. Please answer them. Then first question goes to, that is the substance which gets adsorbed on a solid surface is called A option, the adsorption. Second one is adsorbate. Then C is adsorbent. And fourth one is, that is C, D is none of these. Choose correct answer. I will give just 10 seconds for you people. Answer for this question is, that is the B option, adsorbate. Adsorbate is the right option for this question, because the substance which gets adsorbed on a solid surface is called, that is adsorbate. Second question, the solid that takes up molecules on its surface is called A option, adsorption, adsorbate, C option, adsorbent, and D option, none of these. Select correct answer. I will give just 10 seconds. The correct answer for this question is C option, that is adsorbent. The adsorbent is nothing but the solid that takes up other molecules on its surface is called, that is adsorbent. Therefore, the C is the adsorbent is the right option for this question. Then third question, the spontaneous process delta G for a adsorption is, for spontaneous process delta G for the adsorption is A negative, B positive, C 0, and D will be none of this. I will give just 10 seconds for you people. You choose correct option. Now, in this question, the A option is the right option, because in a spontaneous process, the delta G will for the adsorption is always negative value. It is a less than 0, therefore it is a negative, and that is the A option is the right option for this question. Then a fourth question, Friendly's adsorption isotherm is applicable only at, that is A option, high pressure, B option, low pressure, C option, zero pressure, and D option, none of these. I will give just 10 seconds for you people. You choose the correct answer. The answer for this question is B option. The low pressure is the right option for Friendly's adsorption isotherm, which is applicable only at low pressure. Therefore, B option is the right option. For this, now this complete, that is this session, and for preparation of this session, I made references these books, and this complete this session. Thank you.